Hi, this is Jack from Alpha Charts with an educational video on blockchain and cryptocurrency explained. Now, this is a high level video, so it's not going to get into a ton of granular detail. And it's not all inclusive either. So do your own due diligence. If I talk about something, go ahead and research it more and look around and see what you can dig up and find. This is a very dense topic. There's a ton of information out there. And so again, I'm keeping it at a high level. This is made for somebody that has little no experience with the blockchain, maybe intermediate experience with the blockchain and cryptocurrencies. And it's going to explain how this all works, how they interact with each other, and things that can happen on the blockchain that can cause issues and problems. Again, it's a dense topic. I'm going to add information. Then I'm going to try to put an illustration in there to kind of visualize what we just talked about and kind of go back and forth with that. It should hopefully all build into a very logical, we'll call it story. And that should be, and hopefully you guys could get something out of this. Okay. So let's go ahead and get started. Disclaimer, cryptocurrency is very volatile. It can go to zero. It can go to 1000x or more. Buy and sell them at your own risk. Know your time frame and your risk tolerance. This video is only for educational purposes. These are no intent to buy, sell, or hold any stock, security, crypto, nothing. All right. So there's your disclaimer. Don't do anything stupid. What is crypto? So crypto is designed to work as a medium of exchange. Ownership is stored on something on electronic ledger, and a ledger is basically a database. A blockchain is basically a database, right? But it's a database that uses cryptography. So the ledger controls the creation of coins, transfer of coins, and ownership of coins. And the system is organized through a network of nodes that is decentralized. And we're going to go over all these definitions soon. But it's decentralized system so that there's no central authority that has control over it. So let's talk about cryptography, because that's one of the first things I mentioned. So cryptography, which is really, really important to cryptocurrencies, is the practice of developing protocols that prevent parties from viewing private data. Cryptography has three parts, right? It has the encryption part, which encodes data and it makes it into an unreadable format. It has decryption, which reverses encryption, right, back to its original form. And it has the cipher, which is the algorithm that lets you go from encryption back to decryption, right? So that's the key. All right, so that's cryptography. Now let's talk about cryptography keys. There are two types of keys in cryptocurrencies, okay? There is a public key, which is just like it sounds. It could be widely distributed. You could give it out freely. There's no danger of anybody getting into your cryptocurrency if they have your public key. And there's the private key. So the private key is only you have that key. And that key is very, very important because that's the decoding key, right? The cipher. And that's going to go ahead and give full access to all your cryptocurrency. Now, these keys are always produced in pairs. Okay, so it's really important right there. And then let's talk about blockchain transactions. So basically, transactions are really simple, right? When we go do a transaction, it's going to be take X coins from my wallet and give them to somebody else, right? Then there's a block validator, which is a miner or staked coins. We're going to go into that a little bit later. And that's going to ensure that the private key validates and is authentic. Okay, so that's what the miner or the staked coins do. And that is the basic of a blockchain transaction. So let's go ahead and take a look at this in real life. All right, so we have Richard here. And Richard wants to send a message to Ben, okay? And Richard wants to say, hi, Ben. See you soon at the FinTwit conference in the spring. Great. So what does Richard do? He goes ahead and takes his message and sends it to Ben's public key, which is widely shared, right? And again, the message could be money, it could be words, right, on like a social media account, it could be a contract, it could be property, it could be an in-game item, right? It could be anything really, right? And again, he sends it to Ben's public key, and the public key then will encrypt the message. But remember, this key cannot decode the message. Okay, so it encrypts the message in some random string. Obviously, I just made this up. Now, Ben's private key is closely guarded, and it should not be shared with anybody. All right, it's the only thing that can decode the message, or the purpose of the interaction. Right. Anyone else that looks at this interaction will just see this, and Ben goes and uses the private key, and boom, there's his message. Hi, Ben. See you soon at the FinTech conference in the spring. Exactly the same as what Richard intended and sent to Ben. Okay, so that's exactly the way that transactions on the blockchain occur. All right, let's keep moving. So what is a blockchain? We kind of talked about this already a little bit. It's a ledger, we know that, but it's a little bit more than that. It's a peer-to-peer, decentralized, distributed ledger that makes digital assets unchangeable, or immutable is another word for unchangeable, and works without a third party. Okay, there was a lot in that one, so we're going to kind of start breaking down what that actually means piece by piece, but just understand that is the big definition of what a blockchain is. Now, blockchains offer increased reliability, they offer increased privacy through the cryptography piece. Blockchain, again, is a shared ledger. It's comprised of thousands of computers to maintain a single, there's that word again, immutable, unchangeable ledger. Okay, by definition, that's a blockchain. Now, blocks are created when a transaction occurs and the block is validated. I'm going to go through the whole validation method a little further on. A validated block could be anything, right? It could be crypto, it could be a contract, it could be a deed, it could be a loan, it could be a message, just like in the prior example, right? It could be literally anything. Once a new block is created and validated, it is then added to the blockchain and is immutable, unchangeable. Immutable means something that cannot be changed over time, and is actually one of the key attributes of the blockchain. All right, so Satoshi Nakamoto, he's the guy that, or thing that started it, right? It's a pseudonym for a person or a group who released a white paper titled Bitcoin, a peer-to-peer electronic cash system. They are still anonymous. And a statue of him was made in Budapest, Hungary. And the statue is made of bronze. And when visitors look into the face of Satoshi, they see the reflection signifying, we are all Satoshi. And there you go. That is the statue of Satoshi Nakamoto in Budapest, Hungary. Moving on. Blockchain validation. Okay, so that was one of the things we mentioned. The blockchain has to be validated, and there's two different ways of doing it. Proof of work is one of the ways, and it's an algorithm that protects certain types of crypto, right? Now, we also talk about nodes, and nodes are essentially just points of entry into the blockchain. All right, so and then we have miners, and then miners then use these nodes or points of entry to verify and secure the blockchain itself, right? And so what do miners do? Miners have to solve complex computational challenges, right, to create new blocks on the chain and validate the blocks. So they solve the puzzles and then they broadcast it out to the network, and then as a reward or prize for them doing the work, they receive cryptocurrency for that network. All right, so then they get something out of it too. And without miners, these types of networks could not happen. So proof of work, some good things about proof of work. It's hard to find the solution, but it's very easy to verify. Problem with proof of work, there's a 51% risk, which means if you control 51% of the nodes in the network, you then gain control of the network, and then hackers and nefarious people can go ahead and take over that network and do bad things. Also, proof of work is power and time intensive. You've heard a lot of people talk about the energy consumption because Bitcoin uses proof of work, and also again takes a lot of time. Okay. Now, proof of stake is the other way that most cryptocurrencies are verified, right? So the validators stake or lend crypto to the network, right? That's a very simplistic way of looking at it, but that's what happens, right? Validators stake, which is lending crypto to the network. Now, the staking locks up certain coins for a period of time, making them unusable. Now, these validators then are randomly eligible to find the next block. Now, what happens then is then other validators need to attest that the block is valid, right? So now we have to have consensus, right? And if enough attests that the block is added to the blockchain, right? So then enough people say, yeah, it's the right block, everything's valid. Boom, it's added to the blockchain. At that point, all validators in this process are then rewarded coins. All right. So those are the two ways that crypto is validated. Now, another term that we talked about was it was decentralized and distributed. And then we also have to talk about centralized and talk about the differences between the three of these. All right, so centralized is basically, it's a client server model, right? This is also known as hub and spoke organization. Updates can be pushed to clients immediately and they all adopt the update, right? A problem with this particular way is that if a server fails, then potentially all the clients fail at the same time. And centralized systems also have privacy issues. You know, governments and corporations are all centralized systems. And here's the example. There's your hub, right? And you have all the clients outwards like that. Very common system used in, again, corporations, governments, everything. All right, then we have this decentralized system. So it's an interconnected system where there's no one single entry is the sole authority, right? So not one person is the sole authority, and all nodes have a copy of the plan. And if and when they agree, then they interact. This is much more tolerant to crashes because if one node goes down or a few nodes go down, the system doesn't stop. It access to data faster, right? Again, because you have a node closer to your location, physically closer to your location. So you can access data faster. Still has some privacy issues, and this type has some higher costs associated with it. And this is what a decentralized system kind of looks like. It's all interconnected, but again, one node is not more powerful than any other node. All right, and then we have a distributed system. So it's similar to decentralized, but advances the idea so that each node is actually independent. It runs as a single coordinated system. It increases the chance for scalability and redundancy, and it is more complex and harder to maintain. Now, we talked about cryptocurrency was distributed and decentralized, so it has both those attributes. This is a distributed system in general, right? We have all the different nodes out here, and they all have a central communication network. So that's an example of distributed system. Okay, so now you understand when they talk about decentralized, distributed, what that kind of looks like. And I think that's important because, again, a lot of this terminology is being thrown around out there, but you know, a lot of people kind of have an idea what it means and they're not sure, whatever. And now we kind of defined it. All right, so we talked about nodes many times at this point, and there's three different types of nodes. There's full nodes, and they're responsible for governance and verification of the blockchain. There's mine nodes, which use computers to solve the equations to create new coins and validate the blockchains. Those are the miners, right? And there's light nodes, and that's also known as a simplified payment verification, or SPV. Now, what this does is it checks the blockchain for whether or not certain transactions are present. So if somebody wants to look through the blockchain real fast and find out, hey, did I just send somebody, Jonah Lupton 10 Bitcoin, we could go ahead and search the blockchain and verify whether that transaction actually happened or not. So that's a light node. And remember, nodes can join or leave the network without compromising the entire network. That's the whole idea of decentralization. And all right, let's keep going. Governance. We just mentioned governance. So blockchain governance is not easy with a decentralized system. All right. And what it is, it's the entire set of processes and rules enacted by the platform. So whenever you hear the word governance, it's basically the rules of the platform. It regulates all the functions of the blockchain, the functionality, the ownership, and any changes and future direction, right? So governance is really, really important when it comes to blockchains. And we have two types of governance. There's on-chain and there's off-chain governance, okay? And it's really important that you understand this because it's going to determine the whole future of the chain, really. So on-chain governance, it's based on the rules specified in the blockchain's programming code, because all blockchains are really programming code. And the nice thing about on-chain governance is that it's very specific, right? It's very fast and is very transparent, right? There's no arguing, there's no discussion. It's in the code, it's binary, it's yes or no. Can we do this? Yes or no, based on the code. Now, off-chain governance is a little bit different, right? It's more informal. It's discussions on social media and online forums. You're going to get key stakeholders, you're going to get developers, and you get miners and researchers and end users. And it's slow, it's messy, it's more centralized, right? External actors can have a say in the discussions, which isn't always advantageous or isn't advantageous at all. And it's really not fully inclusive because China has a firewall. So those people don't get to have a say in it, right? And so off-chain governance has its own issues also. All right. Now, governance can lead to forks. And I think we've all heard about forks in blockchains before. And basically what it is, it's an update to the chain that needs to be voted on and approved. That's what a fork is. Now, the blockchain can't force anybody to update, right? And so, the governance decided there's an update to happen, and some agree with it and some don't agree with it, right? That situation then creates a fork. Now, there are two types of forks in a blockchain. There's a potential for a soft fork, and there's a potential for a hard fork. What a soft fork is: a software update that is backwards compatible. Soft forks can modify or add functionality to the blockchain. Soft forks cannot change the blockchain fundamentally. Nodes that did not update can still participate in the blockchain. Backwards compatible. That's the whole idea of the soft fork. So just because you didn't update it doesn't mean that you can't use the blockchain anymore. Now that changes, that's different than a hard fork. So it's the same software update goes through, but it's not backwards compatible with the existing blockchain protocol. That's a hard fork. This causes two separate parallel networks to be formed. Okay. And basically what it does is it creates a future, it identifies a future block, right? It says this block right here is where the hard fork is going to occur. Begin. Now, when the hard fork occurs, the owners of the original coins also get the same amount of the forked coins. And there's a lot of examples. The two most common, though, is there was a hard fork in 2017 for Bitcoin, which created the Bitcoin Cash. And also in Ethereum in 2020, which created Ethereum Classic. Okay, so it's happened on the biggest of blockchains. It can happen on any blockchain. All right, and so here's a visual representation. By the way, this is where I got this particular graphic from. And this is a soft fork, right? So we have the original chain here, and there was an update right here. And so there's your fork, and then it just keeps going. As you can see, the chain is never broken, and these nodes, the non-upgrade nodes, can continue participating in this particular chain in a soft fork. Now, a hard fork is down below. Here's your original chain. It identified this block as a split block. So here what happens is a new chain is formed right over here. And these folks get some of this new chain. So now they own coins in both of these chains. So this chain goes on independently. And then this chain also goes on independently. And these chains no longer can interact with each other or have really anything to do with them, completely separate governance and everything else. So forks are a big deal, especially hard forks. And it's basically a disagreement within the community is what usually causes these types of hard forks. All right. Let's move on to side chains. So there's something called side chains. And so basically, it's a completely separate blockchain that is attached to a parent chain blockchain via a two-way peg. All right. And we're going to talk about what a two-way peg is. So a two-way peg allows assets to be transferred and a specific rate to be determined ahead of time between the parent and the sidechain. Okay. So the way that sidechain works is a user is going to send coins through the parent chain, right? And then it's going to go to the sidechain, hit the two-way peg. There's going to the coins then get locked up. Everything is then confirmed. There's actually a waiting period to prevent double spending and for extra security. And then an equivalent amount of coins will be converted and released on the side chain. And then at that point, side chains, those coins can be used on the side chain, right? So side chains are responsible for their own security and mining, right? If a side chain fails, nothing is affected on the parent chain. And some uses of side chains, beta releases of all coins. They sometimes people will test new features. Side chains may be able to speed up transactions, and there may have potentially lower costs involved in using side chains. The problem with side chains is security is an issue with some of them. Again, they're responsible for their own security. And remember, if a side chain goes down, it does not compromise the parent chain at all. Okay, so if it goes away or goes down or gets hacked, there's no problems there. All right, blockchain speed is a big deal. There are 4 parameters that determine blockchain speed. How fast a transaction is settled is currently a very big issue with some cryptocurrencies. And blockchain speed is one of the challenges preventing mainstream adoption that's currently being worked on, right? And they are working on blockchain speed right now, and they have all kinds of things, that I'm not going to get into to help try to speed that up. The 4 parameters that we talked about for blockchain speed are block size, which is a constant, right? It's written into the programming. Block time, which is the amount of time required to make a new block. That's also a constant. So we really, without forking the blockchain, can't really change that, right? I guess through governance, they may be able to, but those are constants. Now, what aren't constants is network load. It's dependent, right, on the number of active nodes and the number of users, right? That's network load. But the other piece is transaction fee. So what transaction fee does is it creates a priority of transactions. Higher the fee, higher priority. That's a very dependent variable also. So those are the 2 dependent variables, and all 4 of these will affect blockchain speed. Let's talk about the layers of the blockchain, because I think, again, visually, this is very important. So, and you're going to see a lot of information about layers of blockchain and what layer 0 is and 1 and 2. And I've seen big things, but in my mind, this is how I layer them. Okay. Layer 0 is the internet. Blockchains need the internet to work. That's your layer 0. Now, built upon that are blockchains, which are layer 1. It sits on top of the internet layer. And all limitations now at this point are either going to come from the internet or from the protocols of the blockchain itself, right? That's it. Now, sitting on top of the blockchains are the application layer. That's layer 3. And it consists of things like decentralized applications, or dApps, decentralized autonomous organizations, or DAOs, and probably more things to come, right? But that is layer 3 stuff. And this is kind of just a visualization I made to kind of, you have the internet down here. This is your base layer, layer 0. Layer 1 is the blockchain layer, and then you have dApps and DAO and layer 2 and so on and so forth. And all these will, again, I'm not going to get into it, but you've heard of Web 3.0 and Metaverse and other things that I may cover in a future video. But as of right now, just know that these are going to start to interact with all those things. All right, so dApps and DAOs, right? So dApps are built on the blockchain framework, right? And something important about dApps is that they can be layered on top of one another. They don't have to work independently. They can be, again, layered. And they're decentralized, right? And they're fault tolerant. They prevent censorship, and they have no bias. right? They're programs. They don't have any bias unless we program it into them, but they don't. DAOs are organizations. And again, that's a big difference, right? One's an application. DAOs is actually an organization whose rules and governance is embedded in the blockchain. So if you think about it, there's no friction in this particular organization. There's no bias in this organization. If our goal is XYZ and we build our DAO to execute XYZ, all that's going to happen is XYZ, which is pretty amazing. The whole organization is automated with smart contracts. And you can just think about how this could be applied to any organization, trading stocks. I mean, it could be anywhere. And again, it's completely frictionless, which is kind of nice. And you just have to build in the smart contracts to run the organization automation. Okay, DeFi. And again, that's a word that's been bandied around a lot. So DeFi is short for decentralized finance. And what does DeFi do? It basically democratizes the financial industry by increasing accessibility and by being permissionless, no bias, right? And I'm in the United States, but there's other countries around the world that, and even in the United States, that people don't have access to financial institutions. They're very slow, they're antiquated. There could be bias involved in them. There probably is bias involved in them. Again, so DeFi solves a lot of these problems. Now, there's also decentralized marketplaces called DEX platforms. And what these do is they use smart contracts and automation, and they reduce costs and improve trust. Okay, so that's part of DeFi also. And some use cases, again, mortgages, business loans, personal loans, insurance, sending and receiving money, right? There's all kinds of cases, right? And DEX exchanges allow direct peer-to-peer crypto transactions to take place online, again, without a central authority. So that is DeFi the way that I understand it. Again, there's so much more to DeFi, but again, this is just a big high-level overview. All right, let's talk about crypto wallets coming towards the end here. Now, wallets basically is just a program designed to store your public and private keys. Okay, they can send and receive cryptocurrencies. They monitor balances. They can interact with the blockchain. They are essential if you're going to own cryptocurrencies because they have to be stored somewhere, and we store them in a wallet. Now, there are two types of wallets. There's hot wallets and there's cold wallets. Hot wallets are connected to the internet. Cold wallets are not connected to the internet, right? Just that straightforward. Now let's further classify wallets into 4 different types. We have paper wallets, which is a cold storage wallet. And basically you print it out of your public and private keys, right? It's a printout. That's a paper wallet. You have a cloud wallet. That is a hot wallet. And that is usually held online. An example of hot wallets would be if you have a Coinbase account or MetaMask or anything like that. Those are cloud wallets, and they are hot. They are connected to the internet. We have software wallets, and that also is a hot wallet. That is a program that you download. Usually, a lot of these are going to be coin specific, but they don't have to be, and has a higher security level. But these still can be hacked because they are hot and connected to the internet. And the last wallet is the hardware wallet. This is a cold wallet and is the most secure wallet. These are usually on an external USB. Something to remember with these, probably stored in like a safety deposit box or someplace very, very safe. Again, cold wallets, always buy them directly from the manufacturer. You don't want somebody potentially tampering with them and then stealing all your crypto, right? That'd be terrible. Always buy them from the manufacturer. A couple examples would be the Trezor wallet and Ledger wallet. All right. And that is my overview of crypto and blockchain technology. It's very complex, but I think it's very, very important that everyone understands what is going on in this space. Again, this was a high-level overview. This was geared towards the person that has little or no or intermediate type of exposure, or heard people talking about it, and really didn't understand the technology behind things like cryptocurrency and DeFi and that kind of stuff. I believe that we will see this technology more and more begin to infiltrate every part of our world, especially through dApps and DAOs and smart contracts and DeFi and who knows what else is around the corner, right? NFTs are out there, all kinds of stuff. So I think it's really important that we are aware of this stuff and participating in it, to be honest. Obviously know the risks involved too. There's a lot of shady stuff going on in the space, but there's a lot of good stuff going on in the space too. So again, I hope this helped you. I know doing this research helped me a ton. I understand much more. Again, dig into this stuff. I'm gonna have links to the resources, at least some of them that I used, in the description below. You could check that out. Click on the links. All pretty good sites from what I could tell. And again, if you like this type of video, go ahead and like and subscribe to my channel. Follow me on Twitter at AlphaCharts365. I'm on there all the time. I plan on doing some more deep dives into specific cryptocurrencies going forward and taking a look at them. So check out that. Again, I'll post everything on my YouTube channel and my Twitter page. Hope y'all, again, learned something from this. Leave me a comment below. Tell me what you liked about this. Tell me what I missed. I'm sure I missed a bunch. All right. Y'all take care. Good day.